Okay, so today's lesson begins chapter 14, where we will continue to work with trigonometric functions, and we will be doing a lot of graphing, and we will be doing a lot of equations, simplifying, and solving in this chapter. You will need to continue to know those exact values that we learned in chapter 13. So you still need to remember that sine of 30 degrees is 1/2. Sine of pi over 6 is the same, 1/2. Sine of 45 degrees is root 2 over 2. Sine of 60 degrees is root 3 over 2. And you need to know the radian form as well. You need to know cosine and tangent as well. So we're going to first look at the major trig graphs, beginning with sine and cosine, which we learned briefly at the end of chapter 13. So as we go around the unit circle, we want to know what our sine values are. So I'm actually going to scoot this screen up just a little bit. Hopefully you printed these notes off because I think it will help if you already have these graphs and you're just drawing the graphs on the grid. So sine of 0 degrees, what do we all know sine of 0 degrees is? That's your y coordinate around the unit circle. Sine of 0 degrees is 0. We could do this in radians as well. So I'll do the degree one the sine one in degrees, and then I'll do the cosine one in radians. Actually, I'm gonna just write both so that you can always be thinking of it in either degrees or radians. 270 degrees, that would be 3 pi over 2. 360 degrees would be 2 pi. And then we start repeating ourselves. So 360 plus 90 would be 450, which is 5 pi over 2, etc. So what is sine of 90 degrees or sine of pi over 2? It is 1. What is sine of 180 or sine of pi? Your y coordinate is 0. What is sine of 3 pi over 2? So on the unit circle, we're talking about the y coordinate right here. So what's sine of 270? It is -1. Sine of 360 is 0, and then what do we know it starts doing? It starts repeating itself. So this is a periodic function that repeats itself every 360 degrees or every 2 pi. So when I ask you for the period of the function, I'm asking you how long do I go horizontally before I start repeating the exact same graph? And then, as you can see at 360, I would start repeating the exact same figure. So every 360 degrees, or for radians, every 2 pi, depending on which mode you're asked to graph in. So 2 pi will be the same as 360. Amplitude. What is your amplitude? Your amplitude you want to think of as being the height of this curve from the middle. So the middle of this curve is the horizontal axis, which is at 0. So if I ask you for the height of this curve, from the middle to the highest point, or from the middle to the lowest point, they're the same distance. How far is it from the middle to the highest point? It's a distance of 1. How far is it from the middle to the lowest point? It's a distance of 1. So your amplitude is 1. Another way to think of amplitude is this formula. You take the highest point minus the lowest point, divided by 2, and take the absolute value of it, which means amplitude will always be what type of a number? It will always be a positive number. So if we took maximum minus minimum divided by 2 and took the absolute value of that, we get the absolute value of 2 over 2, which is 1. Same thing we got by looking at where the middle of the graph is and what's the distance from the middle to the highest or the middle to the lowest. It'll be the same. So let's move on to the cosine curve. The cosine curve. Okay, so we erase the sine curve. And I'm just going to go ahead and do this one in radians. As we know, degrees would be equivalent, so pi over 2 would be 90 degrees, pi would be 180 degrees, 3 pi over 2 would be 270 degrees, 2 pi would be 360 degrees, and then we repeat ourselves. Where does the cosine curve begin? Well, over here at 0 degrees, this point is 1, 0. Cosine is always the x-coordinate. So x is 1. So cosine begins up here at 1. At pi over 2, this coordinate is 0, 1. So what's my x coordinate? It is 0. At pi, we're down at -1. At 3 pi over 2, we're at 0. And at 2 pi, we're 1. Remember, cosine is always the x coordinate as we move around the unit circle. So we end up with the same looking curve as sine, except it's been shifted. And we end up with that same curve, and then it repeats itself. So what is the period of this function in radians? It is a distance of 2 pi. If I did this in degrees, the period would be 360 degrees. And then it repeats itself. What is the amplitude? Well, from the middle to the highest point, or the middle to the lowest point, is a distance of 1. Or if you did maximum minus minimum divided by 2, and always make the amplitude positive. Good. So we already knew how to graph sine and cosine. They were in the last chapter. Now let's graph, on our next page, tangent. We haven't learned that graph yet. We're going to learn that today. And these are all the parent graphs. You want to become familiar with your parent graphs, because we will be in this chapter stretching it and shrinking it and moving it and things like that. So let's look at tangent. As we move around the unit circle, what is tangent equivalent to? It's equivalent to the y coordinate divided by the x coordinate. So a tangent of 0 degrees, we would do 0 divided by 1 is 0. I'm going to do radians for all of these. Okay, so when we get to pi over 2, tangent would be y over x, which would be 1 over 0. Well, what is 1 over 0? It is undefined. So what that means is, as long as the angle is pi over 2, this will not exist. How do you think we can represent that on our graph? We can have what's called a vertical asymptote. We've seen vertical asymptotes before where the denominator was 0. So that would be a vertical asymptote at pi over 2. At pi, tangent of pi would be 0 over -1, which is 0. At 3 pi over 2, it would be -1 over 0, which is undefined. 2 pi would be back around the circle where it's 0. 5 pi over 2, we start repeating ourselves. Negative pi over 2 is the same as 3 pi over 2. So we've got these vertical asymptotes. Notice they repeat. I go from negative pi over 2 to pi over 2 to 3 pi over 2 to 5 pi over 2. They're all odd multiples of pi over 2. But what does the curve do in between? How am I going to figure that out? Well, to help me figure that out, I'm going to use pi over 4, which will be right here. What is tangent of pi over 4? It is 1. What is tangent of 3 pi over 4? Well, tangent of 3 pi over 4 would be the same as pi over 4, but I'm over here in the second quadrant. What is tangent in the second quadrant? -1. So it would be -1. Then we're at 5 pi over 4. 5 pi over 4 would put me down here, same as pi over 4, but I'm in the t quadrant, so it's going to be +1. And I could continue that pattern, and what I end up with is this S curve that's between the two vertical asymptotes. This is your tangent parent graph. Okay, what are some important features to notice? It always goes through 0, at pi, at 2 pi. So at 3 pi, at 5 pi, it will be going through 0. Vertical asymptotes are at the multiples of pi over 2, odd multiples, I should say. So what would you say the period of this is? What's the distance that I go before I repeat the exact same curve, exact same pattern? I start at 0. I go to pi over 2. Do I start repeating yet? No. When do I start repeating myself? At pi, I start the same design. So my period is pi. What would that be in degrees? That would be 180. My amplitude. Is there a maximum to this curve? No, there is not. It goes up forever. Is there a minimum? No, there is not. So there's no height to the tangent curve. There's no maximum minus minimum divided by 2 because there's no end going up, there's no end going down. So there is no amplitude. There is no maximum or minimum. Good. So let's move on to the reciprocal functions. You want to learn this tangent curve. Know that between negative pi over 2 to pi over 2, what it looks like. From pi over 2 to 3 pi over 2, what does it look like? So let's move on to the reciprocal functions. Now, how many of you have memorized values for cosecant or secant? That's right, none of us have. What have we memorized instead? For cosecant, we use sine and take the reciprocal. We're going to do the same thing. We're going to sketch the sine curve and then take all the reciprocals. So we'll use radians again. So this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. What do we know the sine curve starts at? The sine curve starts at 0. Then I'm gonna draw the sine curve dotted because it's not the sine curve we ultimately want, it's the cosecant curve. So this is gonna be a dotted curve. We know the sine goes up to 1, comes back to 0, goes down to -1, comes back to 0. So this will be my sine curve. We just made it a second ago, and I could keep going, etc. To get the cosecant curve, you're going to take the major sine values and take their reciprocals. What does that mean? Well, we know sine is 0 here. What would be the reciprocal of 0? If I flip 0, it ends up in the denominator, which will be undefined. If it's undefined, it means cosecant won't exist there. So cosecant will have a vertical asymptote. So anywhere that sine is 0, cosecant will be undefined, which means cosecant will have a vertical asymptote. Okay? Other things easy are the ones. What's the reciprocal of 1? It's still 1. So cosecant will have 1. Cosecant will have -1. Cosecant will have 1. Cosecant will have -1. And then, to finish the cosecant curve, all you have to do is take each of these hills and flip them. So the cosecant curve becomes this. And then I can erase the sine curve. The cosecant curve becomes this. And then I can erase the sine curve. Honestly, on a quiz or test, if you leave the sine curve dotted, as long as it's dashed, I won't count off. I'll realize you use that to help you make the cosecant curve. But make sure that the cosecant curve is solid so that I know which one is cosecant and I know that this was just used to help you make it. So let's do the period. How long does this cosecant curve go till I start to repeat the exact same thing? I start at 0, I go to pi. Am I starting to repeat the exact same thing? No, this one's up, down in the negatives. So I don't start repeating the same thing until I get to here. So from 0 to 2 pi. So the period is 2 pi. If you're in degrees, it would be 360. Let's look at secant. So let's put our major secant curves on here. Angles, sorry, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, etc., negative pi over 2. Okay, where does the cosine curve usually begin? That's right. Cosine of 0 is 1. And then cosine of pi over 2 is 0. And then cosine of pi is -1. And then cosine of 3 pi over 2 is 0. And then cosine of 2 pi is 1. And then we start repeating ourselves. But we don't want to make this the solid curve because this is the cosine curve. So I'm just going to make it dotted. And then how do I create my secant curve? I go along, and anywhere that there's a cosine value, I'm going to take its reciprocal. So what is let's do all the zeros first. What is the reciprocal of 0? It ends up in the denominator, so it's undefined. So this makes a vertical asymptote. Reciprocal of 0 is also undefined, so it makes a vertical asymptote. Reciprocal of 0 is undefined. So all of these undefined values become vertical asymptotes. What is the reciprocal of 1? It's still 1. What is the reciprocal of -1? It's still -1. Reciprocal of 1 is 1, and so forth. And then I take each of the curve shapes, and they will be flipped upside down. And if you want to, you can actually take the time to erase the dotted lines. You might want to leave the dotted lines in your notes, so when you go back and study how you made your secant and cosecant curves, you'll remember how you did it. What is the period of the secant curve? How far do I go till I start to repeat the exact same figure? Well, I start at 0. I go. Am I repeating yet? No. Am I repeating here? No. I don't start repeating till here, which is at 2 pi. So my period is 2 pi. If I'm in degrees, it'll be 360. So we have one last graph to create, and that's the cotangent graph. Now, these are all the parent graphs. I'll be honest with you, I don't ever memorize the parent graph for cosecant and secant. I just make sine and then flip it. Take the reciprocal. Same with cosine. Same with secant. I just make cosine and then do the reciprocal. So, for cotangent, you're going to be using the tangent graph and taking the reciprocal. Well, let's put our major angles on here. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2. On tangent, what was tangent of 0? Look at your tangent graph. Tangent of 0 was 0. So when we do its reciprocal for cotangent, it will become a vertical asymptote. What was tangent of pi over 2? Look at your graph above. Tangent of pi over 2 was undefined, which means 0 on the bottom. When we do the reciprocal, where will 0 end up? On the top, so it becomes 0. Tangent of pi, on tangent of pi it was 0, so its reciprocal will be undefined. Tangent of 3 pi over 2, what was it? It was undefined, so when we do its reciprocal, it will become 0. And 2 pi will become undefined, and negative pi over 2 will become 0. Now, the other thing that changes is tangent is an increasing curve. When we go through and do all the reciprocals, what ends up happening is cotangent makes the same curve, but it becomes decreasing. So it looks very similar to tangent, except for it's the decreasing curve, whereas tangent was the increasing curve. Okay, so does everyone have that? Oh, and what would the period be? How long do I go from here to here, and then I'll repeat myself? So how far did I go till I repeated myself? A distance of pi, or 180 degrees. Is there an amplitude for the period, for cotangent? No, because there's no maximum end. I didn't look at the secant and cosecant curves. Why didn't I have amplitudes? Because on the secant and cosecant curve, you've got these shapes. Does this ever stop going up? Does this ever stop going down? So there's no maximum, no minimum, so it also has no amplitude. Good. So now, what are we going to do with these parent graphs? We are going to see what makes them stretch and shrink. We won't be shifting them today, but we will be stretching and shrinking them. If you want to, in your book, there's a graphing calculator lab on page 824. You can practice seeing what happens to some trig graphs when you change some values in front of the angles. If you do that trig graphing calculator lab, be in radian mode. It doesn't tell you that in the directions, but it is radian mode will work best for that lab. You do not have to do the lab for the lesson, but you might enjoy seeing what happens to the curves as you change some numbers in the equation. Again, do that in radian mode. So we're going to go on to what in a trig equation affects the amplitude. Remember, amplitude is the max and minimum, so it's the height of the curve from the middle. And what affects the period. So what could change it from going to 360? So in the sine and the cosine curve, if there is a coefficient, A, in front of the cosine or sine curve, the absolute value of A will be your amplitude. So if you have an equation like y equals 2 sine x, this 2 means my amplitude will now be 2. That means it's going to have a higher maximum and a lower minimum. It's going to vertically stretch it. If it's negative 2, it's still the absolute value of negative 2, which means the amplitude is still 2. We're going to talk about what that negative does to the curve. What do you think it does to the curve? Anybody remember what a negative in front of everything does to other curves? That's right. If we have a negative in front of x squared, it flips it upside down. What we're going to see is the negative sign won't change the amplitude, but it will flip the curve. If there is a number b in front of the angle, so if I change this problem to 3x, so there's a number in front of the angle, that will affect your period. If we're in degree mode, your new period will be 360 divided by the absolute value of whatever b is. So for this problem, the period would be 360 divided by 3, so 120 degrees. That means the original curve that goes to 360 is now going to get squished so that by the time I get to 120 degrees, I'll finish the entire sine curve. Another way to think of it is, if I'm going to get to the entire sine curve, by the time I get to 120 degrees, by the time I get to 360, how many sine curves will I do? Well, 120 plus 120 is 240, plus 120 is 360. How many complete sine curves did I just make? 3. So that number here tells me how many curves you're going to fit in the standard 360 window or the standard 2 pi window. The new period is 1/3 the size of the original. 2 pi if you're in radians divided by b, or 360 if you're in degrees. So this is what we do when we're working with sine and cosine curves. Tangent is just slightly different. Tangent, first of all, has no amplitude. So the A in front of tangent, while it does technically vertically stretch it, it's not going to affect the maximum because all it's going to do is make the curve grow faster. It's still going up forever and going down forever. Because remember, this is what the tangent curve looks like. Okay? The thing that does change is your period. The original period for tangent is not 360. Go back and look at our parent graph. It is 180. So the new period will be 180 divided by whatever b is, or from radians, pi divided by b. So we're going to practice some of these. Now, if you've printed off these notes in advance, which I hope you did, you'll see that there's a lot of examples. We're actually splitting this lesson over 2 days. So we're going to do example 1, A, B, and C today, and we're going to do example 2A. And that means we're going to leave the other 4 examples for the next lesson. I'm going to do this recording over 2 lessons. So we're going to do example 1. They want us to find the amplitude, if it exists, and the period of each, and then make the graph. So let's start with the amplitude. What is the coefficient in front of this cosine curve? There isn't one. So what number is there? 1. So the amplitude is 1. What is the period of this cosine curve? Well, what's the period? Let's do this one in radians. What's the period of the whole cosine parent graph? It is 2 pi. So we're going to do 2 pi divided by, actually we'll do this one in degrees and then I'll practice the radians on the sine curve. So we're going to do 360 divided by 3. So the new period is 120. So we're going to graph this cosine curve. Well, what this means is by the time I get to 120 degrees, I should complete one cycle of the cosine curve. So we sort of need to know other important points. So we need to know the halfway point of the cosine curve. What would be halfway from 0 to 120? It would be 60. We also need to know the quarter point. So we need to know what's halfway between 0 and 60. That would be 30. What's halfway between 60 and 120? That would be 90. And by the time I get to 120, we're going to complete one cycle of the cosine curve. Well, where does the cosine curve typically begin? 1. And the lowest point is -1. Cosine usually begins at 1. Since the amplitude is at 1, that's not going to change because the highest point will still be 1. By the time I finish, I should be back to my highest point. So at 120, I'm back to my highest point. Halfway at 60, I should be at the lowest point. And so that means 30 and 90 are my zeros. And so here's my cosine curve. Now, if I asked you to go all the way out to 360, how many of these curves will I make? That's right. By the time I get to 360, I'll have finished another cycle and another cycle. Each of those is 120. If this were in radians, we would have done 2 pi divided by 3 would be my period. So this would be 2 pi over 3. Are they the same? Well, let's check. What's 2 pi over 3 times 180 over pi? It is 120. 60 would be half of this, which is pi over 3. 30 we know is pi over 6. And 90 we know is pi over 2. If you want to practice the radians. Okay, let's do letter B. For letter B, we're going to graph 1/4 sine theta. Okay, so first thing I find is my amplitude. Well, what's my amplitude? My amplitude is going to be the absolute value of A, which in this problem is 1/4. So what that means is my highest point is only going to be a quarter up and a quarter down. Because remember, that's your distance from the middle to the maximum and the middle to the minimum. What's my period? Is there a B in this problem? No, there's no B, so my period is still 2 pi. So this is going to affect my highest and lowest point only. My period hasn't changed. So by the time I get to 2 pi, I'll complete one cycle. What's halfway between 0 and 2 pi? Pi. What's halfway between 0 and pi? Pi over 2. What's halfway between pi and 2 pi? 3 pi over 2. But I'm not going to go all the way up to 1 and -1. My highest point is only a quarter of the way up. So I'm only going up to 1/4. I'm going only down to -1/4. Where does your sine curve typically begin? At 0. Then you go up to your highest point, which in this case will only be a quarter high. Then you go back to 0. Then you go down to your lowest point, which is -1/4, and then back to 2 pi. And so what ended up happening to this sine curve? And then it repeats itself. It got vertically squished. So your A affects your vertical squish or stretch. Your B affects your horizontal stretch or shrink. Good. What if I put a negative sign in front of this? What would have happened to that curve? That's right. If I put a negative sign in front of this, I would take the curve that I just made and flip everything. So if this were the negative version, this green would represent the negative version. This would be -1/4 sine theta. It would get flipped. Good. Okay, let's go on to C. So we're going to do -6 cosine 4 theta. Okay, so negative 6 cosine 4 theta. What's my amplitude? Is it positive 6 or negative 6? Amplitude is always positive, so it will be positive 6. What's my period? Let's do this in radians. So it would be 2 pi divided by b, which ends up being pi over 2. This means that by the time I get to pi over 2, I should finish an entire cycle of the cosine curve. So this is going to be horizontally what? Horizontally swooshed. By the time I get to pi over 2, I want the entire curve drawn. That means every half pi, I would do a cosine. So by the time I get to 2 pi, how many curves total would I have? I'd have 4. If I went from pi over 2, and then to pi, I draw another one. And then to 3 pi over 2, I draw another one. And then to 2 pi, I draw another one. I would have 4 cycles by the time I get to 2 pi. What is my highest? So in between 0 and pi over 2, before I do the highest point, let's put the middle point. What would be halfway between 0 and pi over 2? Well, that would be a quarter pi. We need our quarter points. What's halfway between 0 and 1/4? Well, what's half of 1/4? 1/2 times 1/4 is 1/8, so pi over 8. And then what's halfway between pi over 4 and pi over 2? Well, this is 1/8 plus another 8 plus another 8. This would be 2/8 plus 1/8 is 3/8. Okay. What would be my highest point? Well, the amplitude tells me from the middle, I'm going all the way up to 6 and all the way down to negative 6. If I had more room, I would really show that this is a vertical stretch. Where does your cosine curve typically begin? Look at the parent graph. Cosine of 0 degrees is how much? Cosine of 0 degrees is 1. But now, because it's been vertically stretched, instead of starting at 1, we're going to start all the way up at 6. Then we go to 0. This will be typical. I haven't talked about the negative yet. Then we go down to negative 6. Then we go back to 0. Then we go all the way up to 6. And then it repeats itself. That would be if this were positive 6. I'm going to draw a dashed curve. This is what it would be if that were positive 6. And then it will repeat itself. But it's not positive 6. It's negative 6. So what's the negative 6 going to do to this curve? It is going to flip it. So now the 6 flips down to negative 6. The negative 6 flips up to positive 6. The 6 flips down to negative 6. And so when I draw my flipped curve, my final curve will be this green one. And then it repeats itself. Look at that. We would have 4 of these curves between 0 and 2 pi. For me, on a quiz or test, I'm going to want one complete cycle. You don't have to show me the 4 curves. You do have to show me the 0 to pi over 2 curve, and you have to show me the halfway point and the quarter points. So you would have to have the axis labeled from 0 to pi over 2. So the last one we're going to do today is example 2a. The other examples we'll finish on the next lesson. So we're going to do example 2a, and this one's a little different. All the examples we've done so far involved an equation, and you made the graph. Now I've given you the graph, and I want you to make the equation. And I can choose. Is this going to be a sine equation or a cosine equation? Well, which one does A look more like? I agree. It looks more like a sine curve. Why does it look more like a sine curve? Because it starts at 0. Cosine, usually starts at 1, or it can start if there's an amplitude higher, but it doesn't start at 0. Sine does. So we're going to make a sine curve. So let's figure out some things. First, we need the amplitude, because that's going to help me figure out A. What is the amplitude of this function? What is the highest point? The highest point is 3, minus the lowest point, negative 3. divided by 2 gives me an amplitude of 3. So my amplitude is 3. What is the period? How far do I go until this repeats itself? That's right, the period is 4 pi. So when we make our curve, we know we're going to use sine. Right now we know A. A is easy. It is 3. We need to figure out the B. The B comes from the period. If you remember, we have a formula. The period equals 2 pi over B. Well, what do we know this period is? It is 4 pi. So 4 pi equals 2 pi over B. How would I solve for B? I would multiply both sides by B. So 4 pi times B equals 2 pi. Then what? Divide by 4 pi. So B equals 2 pi divided by 4 pi. So B is 1/2. So in my equation, we have y equals 3 sine 1/2 x. Is there anything else that this equation needs to consider? You said it's flipped. That's right. The sine curve usually starts at 0 and then goes up. This one goes down, which means what has happened to the sine curve? It's been flipped, which means what needs to happen to the equation? It needs to have a negative sign out front. Good. Now your book does not do a lot of these where you're given a graph and you make the equation. But I will tell you that I will, on the quiz and on the test, give you a graph where you have to make the equation. So make sure you've copied this down in your notes so you have it to study. We'll do that one on the next lesson.